This chapter covers the following topics: network topologies and connection technologies. Completion of this chapter will help you learn how PROFINET devices can be interconnected to form a network. Devices on a PROFINET network are interconnected by switches. A switch in this context is an active network component that detects the destination of each message received and efficiently passes the message along in the direction of the intended device. A switch may either be a standalone device or it may be embedded in another device. Siemens SematicNet industrial communication products include a wide variety of switches and other networking components. Because devices on a PROFINET network communicate point-to-point, this switched architecture greatly enhances network performance, especially when the network structure is well organized. Switches also provide flexibility in network topology, which is the arrangement of devices on the network, and make it easier to adapt the network to changing requirements. Networks are primarily made up of nodes and segments. A node is an active network component, which is a component capable of sending, receiving, and forwarding messages. For a PROFINET network, a node is usually a standalone switch or device with an embedded switch. A segment is the connection between two nodes. A segment can be established using copper or fiber optic cables or via a wireless connection. The physical topology of a network is the pattern formed by nodes and segments. For a PROFINET network, this can be a star, tree, linear, ring, or combined topology. No single topology is best for all applications, so careful consideration should be given when choosing the specific topology for a network or a portion of a network. Keep in mind that the physical topology is separate from the logical pattern of communication between devices on a network. For PROFINET, this logical pattern is point-to-point. Star topology, multiple devices are directly connected to a switch which receives messages from all the connected devices and forwards each message to the destination device. This topology has the advantage of requiring only one switch and is often used in applications where devices are located close together, such as in a single machine or manufacturing cell. The disadvantage of a star topology is that a switch failure interrupts communication to all devices. Tree topology is formed by connecting the switches for two or more star configurations. A tree topology is used in applications where multiple machines or manufacturing cells, each employing a star topology, need to be connected. Linear or line topology is formed when each device has an embedded switch or a dedicated external switch, and messages are passed in a line from switch to switch. In this configuration, failure of a switch or cable segment prevents communication between devices on opposite sides of the failure, but permits communication between devices on the same side of the failure. Linear topologies are often used when devices are dispersed, such as in production lines or conveyor systems. A ring topology is formed by closing the open ends of a linear topology. A ring topology is often used to achieve the highest level of system uptime. In this configuration, each device is connected to two cable segments. When combined with Media Redundancy Protocol Mrp, this means that failure of a switch only prevents the device associated with the switch from communicating, and failure of a single cable segment does not prevent any device from communicating. Media Redundancy Protocol Mrp is defined in the IEC 62439 standard. Devices with embedded switches that conform to this specification can be configured in a ring with Mrp without the need for an external switch. Other devices require a compatible external switch to utilize Mrp. With Mrp, one of the devices in the ring performs the function of redundancy manager, testing the ring to ensure that all switches and cable segments are working. In the event of a failure of a cable segment or switch, the Redundancy Manager automatically reconfigures the network into a new linear topology, allowing all functioning switches to communicate. Typical reconfiguration time is in the range of only 200 milliseconds. In addition to the simple topologies previously described, PROFINET permits use of combined topologies. This flexibility in design allows a network to meet the varied needs of large or complex facilities. What do you think? Drag the terms in the blocks to match the corresponding statements. Then click Evaluate. While a PROFINET network shares many similarities with an office-grade fast Ethernet network, there are some important differences. In addition to the functional differences, some of which have already been discussed, a PROFINET network must operate reliably in conditions where the temperature, humidity, vibration, dust, airborne chemicals, and electrical noise are outside the specifications for an office network. In addition, because environments can vary considerably, sometimes even in a single installation, a variety of connection media are required. For that reason, Siemens SematicNet products include a wide range of PROFINET-compatible copper and fiber optic cables and connectors and industrial wireless local area network (IWLAN) equipment. Shielded twisted pair copper cables are a common connection medium for industrial Ethernet systems, including PROFINET. SematicNet products include an assortment of UL and Cat5 Plus certified 4-core and 8-core fast connect cables to meet the needs of virtually any application requirement. This includes hybrid cables with signal lines and 24 volts DC power lines. Separate 24 volts DC power cables are also available. As shown in the accompanying photos, fast connect cables can be quickly prepared for RJ45 or M12 plug-in connectors using the Industrial Ethernet Fast Connect stripping tool. Fiber optic FO cable is recommended for use in applications with high levels of electrical noise, where grounding problems exist, or where electrical isolation is needed. These cables are also used in open-air systems or where no electromagnetic radiation is permitted. SematicNet products include Fast Connect pre-assembled and unassembled glass fiber optic cables for use over longer distances, and Fast Connect pre-assembled and unassembled plastic fiber optic cables for use over shorter distances. Plastic cables use polymer optic fiber (POF) or polymer cladded fiber (PCF). The Fast Connect fiber optic system enables quick and simple on-site assembly of glass, POF, and PCF cables. In addition to copper and fiber optic cables, PROFINET also supports wireless communication via Industrial Wireless Local Area Network (IWLAN), which brings reliable wireless communication to the industrial environment. IWLAN is based on the IEEE 802.11 standard. As shown in the middle in the accompanying graphic, IEEE 802.11a, b, g, h compatible devices support single-channel communications referred to as single-in, single-out SISO. As shown in the right in the accompanying graphic, IEEE 802.11n compatible devices support multiple-channel communications referred to as multiple-in, multiple-out MIMO, which offers a much higher maximum data rate. IWLAN communication is often used in applications where equipment is in motion or where people need to use mobile devices. However, IWLAN is also used where it is too difficult or expensive to run cables. Siemens offers a broad range of IWLAN solutions. Some examples of these solutions are as follows. Scalance W products that operate at high data rates for efficient wireless communication, even in the harshest industrial environments. This includes products that use MIMO antenna technology to ensure broad bandwidth, wider ranges, and transmission reliability. Scalance W products not only work well for uncritical communication, but also include devices for fail-safe transmission via PROFINET with PROFISAFE. Our coax radiating cables that operate as antennas from Scalance W access points to provide reliable radio links in areas where conventional antenna technology is impractical. ET200 Pro interface module for wireless data transfer, which allows a distributed I/O system to be directly connected wirelessly to a PROFINET controller. Mobile panel for wireless human-machine interface HMI tasks of medium complexity in PROFINET environments. This provides a solution for operating or commissioning distributed or complex machines and plants. What do you think? Select all the correct statements, then click Evaluate. This chapter has provided you with an overview of PROFINET network topologies and connection technologies. This information is important because it summarizes how PROFINET devices can be interconnected to form a network.